Okay, so let's move on now to case study 5. And as before, I'm going to let you just pause the video and you can read the problem statement. Okay. All right. So as we're reading this, we note that we're testing to see if the population percentage is not 15%. Okay. So when there's no change, population percentage is going to be 15%. But when there's a change, there's something going on. Okay, what he's testing for, what he's looking out for, is that it's not equal to 15%. Okay? And very often this is what happens in any sort of quality control situation. We know where we want the population to be, and we don't want it to be too much one way or the other, right? A bank in particular, if a bank has too many loans out, they put themselves at risk. They're not as stable. If they have too few out, they're not making profit, right? Okay, our sample size and our estimate, we know that our sample size is 800 when we read the problem. And our pi hat, our sample estimate, is 10%. Oops, I'm sorry, it's 12%. Be a little careful. Don't get alpha confused with the sample percentage, okay? Okay. We want to use the null distribution, and we want to know, are the conditions for the central limit theorem satisfied? So let's look at them carefully. Do we have a random sample? Yes, it is random. That's given in the problem. The sample size is large enough. If you take 800 times 15%, okay, you're going to find that's 90. If you take 800 times 85%, you're going to find that's bigger than 80. I mean, if that's bigger than 80, it's going to be what, 720, right? So either way, you're going to find out that it's greater than 10, right? So that isn't going to be a problem. Actually, it's 120. Sorry, pi naught times n is 120. Sorry, and pi naught 1 minus pi naught times n, which would be 85% of 800, is going to be 680. So these are both greater than 10. Is it too large? Again, we're going to assume that the bank has at least 8,000 customers, so our sample size doesn't exceed 10% of the population. So now the central limit theorem is satisfied. We know that the null distribution, pi hats that we would obtain if the null distribution are true have a normal distribution. They're centered at pi naught, and the standard deviation is pi naught times 1 minus pi naught divided by n, which in our case means that sample estimates if the null distribution are true have a normal distribution. They're centered at 15%, and this is roughly going to be 15% times 85% divided by 800. And we're going to go ahead and compute that out now. So we're doing a two-tailed test here. Okay? So make sure I'm in the categorical variable section, right? My sample size is 800. My percentage of people that had loans in my sample was 12%. Under the null hypothesis, it's 15%. So I can just drag this down. And notice that the value will be the same as this, except I have to multiply by 2, because I'm doing two tails. Whoops, sorry, I did the wrong one there. hold on. So this is going to be 2 times 100 times. And here we have to look at what side our estimate's on. So our estimate's on the lower side of 15%. So we're going to use norm dist. Okay. There's our data value. There's our mean. And oh, come on. I got one too many commas there. There we go. So our p-value is 1.75% roughly. So let me just kind of illustrate what's going on here. Let's go back to the problem. So here's what we're saying. If the null hypothesis is true, then sample percentages taken from random samples of size 400 look like they come from a normal distribution, and the standard deviation's around 1%, okay? So they look like this: 16, 17, 18, 14, 13, 12. And we got 12%. So the way we compute the p-value for a two-tailed test is I'm going to compute the area in this tail, and then I'm going to multiply it by 2. Now you're going to have to be careful, because notice that if I had 18%, I'd have to use 1 minus norm dist, right? But here I was able to use norm dist. So this is what I computed, but I have to multiply it by 2. Okay? So our p-value is roughly around 1.7%. Our alpha is 10%. So we can easily conclude that our p-value, which is about 1.7%, is definitely less than 10%, which is equal to alpha. So this implies that we reject the null. It's too unlikely for us to get a sample percentage this far from the mean or further if the null hypothesis was true. In other words, if our sample estimate came from this population that sample estimates come from when the null hypothesis is true. And finally, we're ready for our conclusion. So we could say at alpha, at alpha equal to 10%, we find there is sufficient evidence to conclude that the percentage of customers at Mr. Burns's bank holding loans with the bank is not equal to 15%. Okay, good.